You hear me now?
No, you are still very quiet, sir.
Hello? Hello?
Hello?
Uh, Are you hear me now?
No.
Hello? Hello? Hear me now? Hello?
Hello.
Hear me now?
Kind of.
Are you hear me now?
Speak again.
Are you hear me now?
A
Hello?
bit, yes.
Okay. We can start now?
Sorry?
We can start.
Yeah, we can start.
Okay. First topic about forces and motion, beginning with the units of measurement. What's the meaning of measurement? Comparing any physical quantity with a standard to determine its relationship to standard. This standard is called unit. All measurable quantity expressed in number and unit. It's like a story when we go to the seller to sell something like tomato. Is a known amount. If this amount equal to the mass of 1 kg load 3 times, so its mass equal 3 kg. Okay.
Okay.
For complete definition of our physical quantity, we need the amount and the unit. We need what? 3 kg or three boxes of tomato or three. So we must tell about the unit. 3 kg, 3 grams, 3 pound, standard international unit. Length with meter, mass, kilogram, time, second. So it is. Its name abbreviation is MKS system. System used internationally. The system is also called SI system international. There are some transformation between units from centimeter to meter, divide 100, from meter to kilometer, divide by 1000. We can make it by times 10 powered to negative 2 or times 10 powered negative 3. For opposite process from here, we can reverse the process from kilometer to meter times 1000 or times 10 power 3, and from meter to centimeter times 100 or times 10 power 2. Gram, kilogram, ton. Divide from gram to kilogram, divide 1000 or times 10 power 3. Gram to ton times 10 also 10 power 3. In the reverse process, we can reverse the mathematics process. 10 times power 3 times 10 of power 3. Second, minute, hour, 60, 60, 60. You know? Okay.
Okay.
Now, powers prefix. There is unit. To facilitate our measuring process, there is unit like meter for length. We can make multiples or submultiples. Multiples for what? For the larger distance, like the length of street. We need two multiples meter, 10,000. The name kilometer. Kilometer equal 1,000 meter. So is 10 power 3, 3 zeros, 10 power 3 from meter. If you know what I say now, we can go to the another point. There is some details you must be know. If you know this details, we can go to another point, as you see. For complete. Hello? Hello?
Hello, sorry.
Are you hear me?
Yeah, I can hear you.
What about the transformation between the unit and the multiples and submultiples? If you know this point, we can go to the another point.
Yeah, yeah.
Okay, so I ask you the question to indicate this point. You can express the 9.9 mega meter into kilometer. You can ask it.
Um,
Okay, I tell you.
mega.
Mega, from mega to meter, from megameter to megameter and degree. We can exchange this example by micrometer. Okay, from micrometer. This micrometer from the to facilitate this problem. Firstly, then we can go to the complex one from kilometer to micrometer. From kilometer to meter, 10 power 3. From meter, 10 from kilometer to meter, 10 power negative 3. Okay, from meter to the mega meter, 10 power 3, sorry, 10 power 6. Okay, so from kilometer to megameter, 10 power 9. Okay,
Okay.
from kilometer to meter times 10 power 3 from meter to micrometer, 10 power 6. So the total 10 power 9. As you see, there is nano from the unit, 10 power of negative 9 from unit, micro, 10 power of negative 6 from unit, milli, 10 power of negative 3 from unit. What's the meaning of what I see now? Okay, we can take nano, we mean by this, if we need to transform from meter to nanometer, we must multiply the value times 10 of power 6. For reverse process from nanometer to meter times 10 power of negative 6. Are you understand now?
I think.
Take example. From micrometer here, 10 negative 6. We get 10 negative 6. We can get nano, micrometer, nanometer. Nanometer, 10 power of negative 9. So from meter to nanometer times 10 power of what? 9 from table.
Yeah.
Reverse process from nano to meter, 10 power of negative 9. So we can say from greatest to smallest, positive power. From smallest to greatest, negative power. Okay? Are you
Okay.
understand now? Okay.
Yeah, let me just write it down very quickly.
So from meter to millimeter, please tell me.
6.
Times 10 power, millimeter.
Oh, 3 minus 3.
From
No,
meter to millimeter, from greatest to smallest, positive 3. From smallest to the greatest, negative 3. Okay?
okay.
From kilometer to meter. What is the greatest, kilometer or meter?
Kilometer?
Okay, so it is from kilometer to meter times 10 power 3 from greatest to smallest. Okay? You must keep this table as you see.
Yeah.
Negative 9 from what? 10 power negative 9 from what? From unit, from meter or second or gram. Okay? Micro
Yeah.
of the symbol meo. 10
Okay.
power of negative 6 from what? From unit.
Yeah, millimeter.
Milli. 10 power negative 9 from unit. We can go to the deep understand of this. What's the meaning of that? Take example for millimeter. We can get, it's a story, it had a story. Meter divided into 2,000 pieces. Each piece have nickname of milli. Each piece of 1,000 piece, millimeter. There are 3 zeros, so it is 1 over 10, 1, 2, 3, power 3. We can get this number in the from denominator to numerator, so we reverse its power like this. So millimeter equal 10 power negative 3 from meter. So any number of meter like 9.9, 9.3, 7.8, 215, we can multiply it by 10 power negative 3 so we can transform it into millimeter. Take example. transform 315 millimeter into meter. Solve, please.
Sorry, my dogs were barking. Can you repeat?
Transform 315 millimeter into meter unit. Is the smallest of greatest.
Smallest. So
So
10 power negative 3.
okay, well done. Meter. We can get another example. um, 469 meter into micrometer. Micrometer equal what? Mayo. Micrometer of symbol Mayo equal what? The value.
10 power negative 6.
Okay, keep this value in your mind. So from meter to millimeter. From what to what? From greatest to smallest. So
10 power 3.
okay. 10 power. 10 power what? From
3.
table. No, we forget.
Wait, milli or micro?
Micro.
Oh, 6. 10 power 6.
Of symbol Mayo.
10 power 6. Sorry, I misheard.
Okay, well done, well done. Milli, micrometer. Okay. This is very important transformations. It is the basics of physics. The next point is scalar and vector. What's the meaning of scalar and vector quantities? Physical quantities is divided into scalar and vector quantities. Scalar quantities don't need anything except magnitude. Scalar quantity, a quantity has magnitude size only, and is described by its numerical value, like distance, mass, speed, volume, time, and temperature. If you measure the temperature of a child, we must need the value 37.5 centigrade only. We don't need direction or the mass of milk, 2 kilogram of milk. Only the value, magnitude only. We don't need its direction. But vector quantities, we need the magnitude and direction. Vector quantities, quantity which has both magnitude and direction, and both should be mentioned to describe, like displacement, weight, velocity, and acceleration. If I ask you about my cat, where is my cat? You must tell me your cat go 100 meter east direction. If you tell me 100 meter only, we can find that. Okay? It is displacement. Okay? It is vector quantity, magnitude, and direction. So displacement is vector quantity. Weight is a type of force. My weight and your weight and anyone weight equal something by Newton to the center of the Earth, 600 Newton is the magnitude. And the direction of this weight is to the center of the Earth is the direction. So magnitude and direction. So weight is from the vector quantities. Velocity. Velocity like speed, but velocity we must tell about the magnitude and direction. Two cars go 80 kilometers per hour. Speed. Car A and car B. Car A go the east direction. Car B go in west direction. So after 1 hour, the distance between each other is 80 and 80, 160 kilometers, where one of them go in east direction and the another one go in west direction. You understand?
Kind of.
Hello?
Hello.
You understand what is the difference between scalar and vector quantities?
Kind of.
Scalar quantities need what only for complete definition? Magnitude only. Vector quantities need magnitude and direction. Okay. Speed. Do you know how fast you can run? The fastest runners in the world can run 100 meters in just in second. It is Usain Bolt is a runner, the fastest runner in the world, Usain Bolt. That means they all cover 10 meters each second or 10 meters per second. This is written as 10 meters per second. Speed equal distance over time. Distance measuring unit is meter. Second measuring unit, time measuring unit is second. So the unit of speed is meter per second. We can make a triangle of rule here, distance and the velocity here and time. If we need velocity, it is distance over time. Time equal distance over velocity, and distance equal velocity or speed times time. Okay. Hello.
Hello. Hello. Sorry.
How do you understand this relation?
Yes.
Okay.
Yes.
So to calculate the speed meter per second, distance moved by meter, time taken by second. We can solve this question, please. Please read and answer. Hello, Adam.
Hello.
Please read and answer.
Yeah.
I can't hear you.
2.5 meters per second.
What is the rule? Tell me about rule and your substitution. You can solve it in your notebook now.
The formula is distance divided by time in seconds equals speed.
Okay,
The distance is 400 meters
okay.
and the time is 160 seconds. So I divide 400 by 160 and I get 2.5 meters per second.
Well done. Note, you must write the details of solving problem in exam. Examiner need this. Another one, you can read and answer. Example number 2, an athlete. Okay,
So the formula is
okay.
distance times average speed to get the time. So
No. Times divided by.
sorry.
So I tell you to facilitate in yourself to yourself by the triangle of rule. It is a very easy method to keep our rules. Here speed, here distance, sorry, here speed, here time. We need time. So it is distance over speed. Okay?
Wait, sorry to interrupt, but shouldn't distance and time taken times to make speed then?
Please write it in your notebook. Distance here in the top of triangle, in base, speed, v, time t. We need here time. So time equal distance divided by speed. Please write down this rule in triangle to facilitate. Okay?
Okay, so
So they
formula
solve formula now.
the formula is distance divided by speed and
Well done.
it says 4 kilometers. So
Please
I
note, unit here by kilometer. We must transform it into meter by
10 power
multiply
3
it by 10 power what?
minus 3.
From greatest to smallest. 10
Yeah,
power? 10 power what? Positive 3. Positive 3. From greatest to smallest, 10 power, positive 3. Okay?
plus 3, yes.
Complete, please.
So 4,000
Okay, well done.
divided by 3 meters per second is 1,333 seconds.
Well done. What about displacement and distance? We have a story to understand the difference between displacement and distance. Displacement, it is the shortest distance between the start point and the end point. But distance is the overall journey. One day there is a student, its name Kalbuza. Kalbuza go wake up and go to restaurant in point B from his home in A to restaurant, then go to the juice corner, then to the cookies corner D, finally go to his school